Welcome to How Do Fictional Characters Feel, where we will be exploring the emotional states of characters in various young adult novels. We are working with Professor Taraneh Matloob, an associate professor in literary education at the University of Northern Iowa, and Sadisha, an instructor at the data science department, as our internal mentor. My name is Anna Moise. I'm a fourth-year undergraduate majoring in data science.
And I'm Sue. I'm also a fourth-year majoring in data science. In our project in general, we would like to recognize the experience of African-American fictional characters through a collection of award-winning books. Professor Matloob theorized that people of color characters in young adult novels depict traces of complex traumas unlike white American characters. So looking at these novels, we would like to identify such negative emotional patterns. We are working with 26 award-winning young adult novels written by African-American authors. In addition, this quarter we also have the emotional classification results of our paragraphs, which are our time units that are obtained from our sentiment analysis models last quarter. In terms of our main tasks to deliver to our external mentor, we would like to computationally analyze and visually represent the structures of these multicultural narratives and the characters within, with a particular emphasis on identifying critical times that evoke heightened emotions among multicultural characters. On our path to final deliverables, in the next slides, Anna will first talk about how we completed our explorative data analysis to identify critical times, and also about how we build sentiment analysis models that assign emotions to our text units. After that, I will talk about the two major problems we tackled this quarter that are related to the character identification task we have on screen, which indirectly actually affects our main task, critical time tagging. Now, Anna.
Yes, as Sue briefly mentioned, last quarter we trained a 3-class model and an 8-class model on our data to predict emotion in a given paragraph with the respective emotions listed on the slide. Here's how it works. In the sentence, "She's not, I protest," the 3-class model predicted it with being a neutral statement, while the 8-class model predicted it being an angry sentence. Not only did we generate visualizations which predicted the emotion per paragraph per novel, but we also separated by character to see their individual critical times. We can identify critical times. These are moments as defined by Professor Matloob as instances where a character experiences a dramatic shift in emotion, for example, joy to sudden fear. Here we can see there was a sharp change in emotion of the character Quinn from All American Boys, where going from negative emotion to suddenly positive and then negative again stays for a good few paragraphs. We can assume that the character experienced a short period of time where their emotions were happy, positive, before some sort of traumatic event that kept them emotions negative. These are most important to Professor Matloob's research, so we need to be able to generate robust data that demonstrates the change in emotion over time. Unfortunately, though, working with character names was very difficult. In regards to names, there is an added layer of difficulty because we have to map multiple names to a character. Firstly, our name scrapping technique from last quarter was not very accurate, as we were using linear functions to identify the characters in paragraphs, which would loop over all character names in a list and find instances of those names in a paragraph, even if they weren't the subject. However, many characters also in our novels oftentimes appear with different names, whether it's their full, last, first, nickname, or even a secondary nickname. On the screen, you can see multiple names of one character referred to in a novel. If Deepak is only referred to as D or Tu throughout the novel majority of the time, as you can guess, then we should not waste calculating power to search for another name that won't yield any results.
So to solve that problem, our first task this quarter was to increase the accuracy of our mention extraction function, which identifies the characters mentioned in a paragraph, which is our time unit. As the main aim of the project is to create a time series of the emotional journeys the novel characters are going through, we need to be able to accurately identify the characters appearing in a paragraph. The preliminary approach we took this quarter was identifying character names through name entity recognition models that would extract the subject from the linguistic structure of a sentence. However, tagging the characters were not the only problem. Here, let's take a look at this sentence from one of our paragraphs, which is a sentence clearly tagged as negative by our model. We can see that in the second sentence, the pronoun she clearly refers to the mom character, which we borrow from the first sentence. However, as the mom entity does not appear as a nominal subject in this active voice sentence, our entity recognizer does not extract that. To solve this problem, we strengthened our models with coreference resolution tasks that found all expressions that refer to the same person in a task, which helped us diminish the fragmentation appearing in our time series due to alternative names of characters Anna just mentioned. We validated the results of our models by calculating the overlap percentage of the character mentions extracted from our dependency parsers to the character mentions extracted from our linear function. So it is the comparison of the number of characters that we were able to get using our dependency parser to the number of characters that we know they actually get mentioned through linear function. This overlap percentages are not definitive answers. High percentages does not imply better working models. It is merely a measure of whether we were able to eliminate false positive character names from our previous work, focusing only on characters who are the main actors. Our second task, not mutually exclusive from our first task, was to eliminate character ambiguity from paragraphs. To draw the time series of a character's emotional journey, we mapped the paragraph's emotional sentiment analysis classification to the related character. However, when we extracted all the character names that are mentioned in a paragraph, we noticed that not all characters are the subjects of the emotions, merely getting mentioned in a sentence. To decrease our false positive rate for character identification, we adjusted our named entity recognition models to extract only nominal subjects from active voice sentences and objective prepositions from the passive voice sentences. And for the deliverables, we refined our delivers from last quarter and were able to make the following. And now Anna will talk about them.
Okay. We made bar charts to visualize the 8 emotions per book. There is color coding for each emotion label, and we can see here that our model detects a diverse range of emotions throughout the book. We can also see clusters of green and purple, which correspond to the emotions of fear, joy. And the pie chart on the right shows that these emotions were, in fact, some of the highest probability in the novel. This was the novel level visualization, but as mentioned earlier, we made character level visualizations, which show the same things, but are specific per a character that we have designated as a main character. In these 2 graphs, we're examining the sentiment of Styx from the novel The Season of Styx Malone. Similar to the previous graph, we can see that joy and fear are some of the most common emotions, with clusters appearing throughout the novel. Now, it is worth noting that the readability of our visualizations does depend per novel, as there is a wide range of paragraphs that appear in the text we're using. Hence, we have created many options for Professor Matloob to use in her analysis. Here is a graph that focuses on gender as a category, as asked for by Professor Matloob. She wanted to investigate if women have more negative emotions than their male counterparts. But as you can see here, there are very few paragraphs where the female character appears. It would be unreasonable to correlate her negative emotions with the lack of positive emotions we see from male character. And unfortunately, of our 26 books, only a handful of them had a reasonable ratio of male to female characters deemed as main characters. Another issue we ran into, only post-analysis actually, is that most of the novels take place in first-person perspective, and therefore we simply do not have sufficient information on non-narrator characters' emotions because they would only be conveyed via dialogue or the narrator's perception. And we have communicated these issues to Professor Matloob and proposed some solutions.
Yes, as Anna also mentioned just like a minute ago, although we obtained substantial results, our work still needs improvement. Our work mainly endeavored to integrate computational approaches to a domain traditionally not using such methodologies. We were trying to automate the emotion, character, and critical identification process as much as possible so that people don't need to read these books to come to conclusions, saving them hours. However, since we were working with artworks and most of the time we had to do specific adjustments to our models to be able to include a very creative novel, we had to work closely with Professor Matloob to decide what names were correct and which ones were important enough to consider for our analysis. In the future, we would like to fix this dependency to an external reader problem.
And we also believe that it would be interesting for Professor Matloob to investigate the relationships between characters of other races, as well as sexualities and ages. There could be more insight to the complexities of character development throughout the novel when considering these things. Now, Professor Matloob would also like to look at power dynamics between characters, whether it is social, economic, or something else, but this project will require retraining a model for classification purposes. Currently, we believe it is more important to consider a different corpus of novels that are written in third person, which would make it easier to catch emotion changes in characters. Now, that being said, we've greatly enjoyed working with Professor Matloob the past 2 quarters and exploring the intricacies of language and emotions in novels. We really hope that our work has helped her research and that her future steps build off of our work. Thank you so much.
Thank you.